Ladies and gentlemen, your host, Gordon Zulu. So today we have one interesting question which reads to say, let x be a random variable with the probability density function given by this. So there is one criterion which we are interested in. Remember, they have given you something which we need to put into consideration, the modulus. We know from functions and other topics in mathematics that modulus means to say if any number is negative, then that number is automatically a positive. So they're telling us to say if it does not obey this, then it is a zero. So what I'm trying to say here is, remember, x can take any number. Remember, they're telling us to say x is less than or equal to 1. So which means it can take any number, even negative 100, negative 1000. But they have given us a restriction by putting the modulus, which means we are having a range which is hidden in these modulus. And that range is -1, where x is greater than or less than 1. So this is the range that is here, but it has been hidden in these modulus. So what we do now is, remember, they want us to find the constant c. So if they're telling you to find the constant c, you need to put into consideration one thing. We need to know that the shift from negative infinite to the shift of positive infinite, when you are dealing with what is referred to as the integral under the probability density function, the resulting outcome is always a 1. Why? Because there is a width and the area under the curve is always a 1. So we'll use that principle for us to be able to solve this kind of a question. So having explained, let us now put this in mathematics. So we know for sure that the lowest value is -1 and the highest is 1. And the expression they have given you is cx squared dx. Remember, this is a derivative of the cumulated density function. So having done this, we know for sure that the law that I stated earlier, this is the law that I stated earlier, where we are having this equal to 1. So this is the law I stated earlier, where this v is any discrete variable. Remember, discrete, these are simply counting numbers. So having done this, we know for sure that here c is a constant which we can factorize and outside the integral. So we have c, the integral of 1, -1 x squared, and if you are to integrate this one, you will have the value to be x to the power 3 over 3, 1 -1. So that is what we are having. So now that we have that, we know for sure that these are equal to 1 as per property which we have stated above, where we just get this one and put it in there. So we have 1 to the power 3 over 3 minus -1 to the power 3 over 3 equal to 1. So having done that, we know for sure that any number any number that is of a power to 1 is still 1. So we're having 1 over 3 minus -1 to the power 3 is -1 over 3 equal to 1. So this is what we are having. Then we know for sure that negative times negative is positive. So we are having 1 over 3 plus 1 over 3 equal to 1. So having done that, we know for sure that if the denominators are the same, just add the numerators. So we are having a 2 over 3 equal to 1. Then from here we cross multiply. So before we cross multiply, let us just multiply so that we can remove the braces. So c times 2 is 2c over 3 equal to 1. Then 3 times 1 is basically 3 divided by 2. The answer you get is 3 over 2. So this is how you handle such kind of situations. So having done that, the second question is telling us to find the expected value of x together with the variance of x. Remember, There are some properties that I gave you. I will attach the link in the description of this video or the comment section so that you go check the properties of variance. Remember, we had one of the properties of variance, which is there is no variability in a constant number. But remember, here we are dealing with expectations. So when we are dealing with expectations, the variance of x is defined by x squared minus x of such kind. So let me just rewrite this somewhere here. So the expected value of x squared minus the expected value of x. So this is the formula that we are dealing with when we are dealing with variance. Then remember, for us now to be able to solve the expected value, remember the expected value of x, in other words, is just you finding the mean. But how do you find the mean of such a function, the one given here? Remember now the value of c is already known to be 3/2. So let us just rewrite it here. So this is what we are having as the expression that we are from getting, where they have said the modulus of x less than or equal to 1, otherwise it will be a 0. So having now understood what we are dealing with, so for you now to be able to solve the expected value of x, remember the expected value of x is where you multiply every expression that you have been given with an x. So now we need to integrate this one, but before we integrate this expression, we need to multiply it with an x. So if we multiply that expression with an x, we are having the integral of 3/2 x squared multiplied by an x. So x times that, we are having the integral of 3/2 x to the power 3 dx. So now we can continue. So having done this, we know for sure that here we have a constant which we can put outside the integral, and the integration of x to the power 3 is the same as x to the power 4/4. So having done that, we now know for sure that they are telling us to say we should find the expected value of x, and the range which we have been given is what we interpreted here as -1, where x is greater than or equal to -1 but less than or equal to 1. So we are using this expression for us to be able to solve the expression that we want. So we are putting we are putting a +1 there and a -1. So +1 and a -1 there as per rules. So having done this, we continue. So we just replace here 1 to the power 4/4 minus -1 to the power 4/4. So this is what we have now. So we know for sure that 1 to the power 4 is still 1/4, and -1 to the power 4 is 1/4. And remember, these are the same, and if they are the same, the resulting outcome will be a 0, and any number multiplied by a 0 is still a 0. So this is how you calculate the expected value of x when given the probability density function. Remember, they further want you to calculate the variance of x. We know for sure that for you to find the variance of x, remember now that the formula that we have when dealing with the variance of x, as we discussed earlier, is this formula here, where the expected value of x squared, you do not have it. So now that you not say you do not have it, then the expected value of x is just the one you are from calculating on top, which we said that it is the mean. So this one is already a 0, and any number with a subtracted by a 0 is still that number. So we are just dealing with this expression. So let us now handle this expression. So for us to be able to handle this expression, remember here they're telling us to say we should square x. So we do the same, but in this case we will have 1 and -1 there, they're still the same. But remember here it was squared, and you will multiply this with x squared again. The reason why we are multiplying with x squared is because here they only squared x. So take note between the variance and the mean. So we are having the integral of 1 and -1 there, where we know for sure that this and that is x to the power 4. And you can factorize the 3/2 to be outside the integral, and the integration of x to the power 4 is x to the power 5/5. Where now we're having numbers which are 1 and -1. So having done that, we just replace. So 3/2, open bracket. Remember 1 to the power 5 is still 1/5, minus -1 to the power 5 is still -1/5. So negative times negative is positive. So is positive. We're having +1/5. Then 1 plus 1 is 2. So we're having 2/5. So remember, this is now the resulting outcome. When you add 1 plus 1 is 2. Remember, if the denominators are the same, you just add the numerators. So we know for sure that here we can cancel. And we are having a 1 and a 1 there. Then 3 times 1 is 3 over 1 times 5 is 5. And 5 into 3, the resulting outcome we get is 0.6. So this is how you calculate such kind of a probability. So this is how we solve this kind of equation. Your host, Zulu.